Welcome back to another video. Today we are going to use the division algorithm to find the quotient and the remainder from the two given numbers. Take a look at this example 2.1.1. We need to find quotient and the remainder satisfying theorem 2.1.1 from the following values of A and B. So we start with B, which is 6, and A is 7. Okay, just like we have 60 as the dividend, and A is divisor. So when we divide 60 by 7, we're gonna have quotient and the remainder, right? So by division algorithm, let me write it again. Okay, let me write like this. When A and B are integer and A is not 0, there exists Q and R such that B equal to AQ plus R, where R is greater than or equal to 0 and less than absolute value of A. Okay, so now B is 60, A is 7. What do we have? Okay, so there exit. Q equal to 8. Let's use 8. Why? Because 7 times 8 is 56. And R is 4. Okay, and R is 4. Such that B equal to AQ plus R, where R is greater than or equal to 0, less than absolute value of A. Okay, so let's plug in the value. We know that 60 equal to A times 8 is 56, right? Plus 4. Okay, plus 4. Okay, let me go back to this one. Okay, A is before, right? So A is 7, Q is 8. And what about the remainder? As we can see, the remainder is greater than or equal to 0. This one is 4, right? And less than absolute value of A, and A is 7. Okay. Now what about B being minus 39 and 6 is the divisor? So what do we have is there exists Q equal to which number? So when we divide, so when we have 39 and A being 6, so let's multiply by minus 7. Okay, and R, what is R? R must be 3. Why? Because when you multiply 6 by minus 7, you get a half, minus 42, and the remainder must be positive, right? So you have to add it by 3 in order to have minus 39. Okay, let's use theorem. Let's use the division algorithm. So we get a half such that B is 39, right? A is 6, Q is minus 7 plus R, where R is greater than or equal to 0 and less than absolute value of A. And B is minus 39, right? A is 6, Q is minus 7, R is 3. And then, as we can see, the remainder is 3, and it's less than absolute value of A, which is 6. Next one here. Now B is 111. A is 11. So let's use the division algorithm to divide 11 by, to divide 111 by 11. Okay, what do we have? So we're gonna have Q, which is the quotient, which is 10, and remainder is 11, right? Actually it's 1, not 11. Okay, such that B equal to AQ plus R, and R is greater than or equal to 0, less than absolute value of A. B, which is 111, which is turns out to be 11 times 10 plus 1. Alright? And R is greater than or equal to 0, less than absolute value of 11. Okay? So that's what we have right here by division algorithm. Now what about divisor? Dividend being minus 114, and the divisor is 9. Remember that the remainder must be positive. So I gotta use this. Okay, let me think. What is Q? What's the quotient should be? So we know that 9 times minus 12 is this figure, right? Minus 108. 9 times minus 13, you're gonna have minus 11. Minus 117. So I gotta use Q, which is minus 13, and remainder is 3. Okay, remainder is 3, such that B, which is AQ plus R, where R is greater than or equal to 0, less than absolute A. Okay, what about B? B is minus 114. Alright, what is A? A is 9, Q is minus 13. Okay, and then plus R, which is 3, right? Because this figure is minus 117 plus 3, which is minus 114. Alright, so what is the remainder? The remainder is 3, which satisfy this inequality because A is 9. Okay. Next one. B is 1205 and A is minus 12. What do we have right here? Okay, so there exists Q, which is, okay, let me think, minus 100, right? It's not good enough. I think it is minus 100, this one. Okay, because 12 times 100 is going to be minus 1200. But if you multiply minus 12 by 101, so we're gonna have this figure. Okay, this figure, and we need to add 7 in order to have. Oh, this is positive number. I'm terribly sorry. Okay, so you have to multiply it by negative number. So your Q must be negative. Okay, let me think again. Let me try to figure this out again. For this one, it's gonna be this much. Okay, and what about here? This one right here is 1212. So I have to choose Q, which is minus 100. Q must be minus 100. And what is the remainder? The remainder is 5, right? Such that, okay, B equal to AQ plus R, and R is greater than or equal to 0, less than absolute value of A. What about B? B is 1205, right? What is A? A is 12 and Q is 100, okay? And plus 5, right? So R is going to be greater than or equal to 0, less than absolute value of A, okay? Less than absolute value of A. That's what we have, right? And absolute value of A is 12, right? Oh, R is 5. R is 5. Just like that. And the last one. Okay, if B is minus 175 and A is minus 5, what do we have right here? Okay, so the axis, what is the value of Q we need? Okay, what's the value of Q? We're gonna have minus 5 times what number? It's going to be a positive number. Okay, 35, right? If you multiply it by 35, you're gonna have minus 50 minus 25. Okay, right? Because 5 times 30 is 150. 5 times 5 is 25. So you're gonna have minus 175. So our Q must be 35. Okay, and the remainder is 0, such that it satisfies this equation B equal to AQ plus R, where R is greater than or equal to 0, less than absolute value of A. And what is B is minus 175, A is minus 5, Q is 35, plus 0. Okay, and the remainder being 0 satisfy this inequality. Okay, and R is less than absolute value of 5. Okay, but I think we have to substitute all the value of R, right? I forget to substitute. Our R right here is 4. Okay, is 4. Our R right here is 3. Our R right here is 1. And 1 is greater than 0, less than 11. Our R right here is greater than or equal to 0, less than 9. Okay? Absolute value of 9. When for E, R must be 5. So you're going to have 5 greater than or equal to 0, less than absolute value of minus 12. For this case, R is 0. Okay? So this is how to use the division algorithm to find the quotient and the remainder when the dividend and the divisor are given. That's it for today, and see you in the next video.